This is hopefully the last part of Euclid Book 2, proposition number 5. And Euclid left out several steps, which I had to, of course, include in here so you could see this for yourself. Now, let's pick up from where we left off. We have a rectangle AKLC. AKLC. And then we have a rectangle CDHL. CDHL. And if you were to add these two together, you would get the same amount of area as though you were to take the rectangle DGFB and add it to CDHL. So this rectangle here added to this rectangle here is the same as adding this rectangle here to that rectangle here. Which means we have a nomen. And the nomen includes rectangle CLHD, DHMB, and of course HGFM. So these three pieces right here are a nomen, and they're known as the nomen NOP. See that little dotted line there? That's what that is. Okay. Now, we've now established that AKHD is equal to this whole nomen right here. This piece plus this piece plus this piece. Now we have to go on to the next piece of the puzzle. We have two parallel lines. They are CE and DG. Okay? And we have a line here, BE, that cuts through both of them. And because of that, DHB, this angle right here, is equal to CEB. CEB, this angle right here. Now, line CE is equal in size to CB. We established that a long time ago. Okay? Because of 1,5, of course now we can also say by 146, okay, by proposition 146, CB and CE are exactly the same size because we drew a square. Alright, so now we can say that angle CEB, this angle right here, is equal in size to CBE, and that's because of Euclid Book 1, proposition number 5. So if this angle here is equal to that angle here, and this angle here is equal to that angle there, then by the transitive property, angle CEB is equal in size to angle DHB. So this one here is equal to this one here, and this one here is equal to this one here, and so on and so forth. We could go back and forth and yada, yada, yada. Alright. Because DHB, this angle right here, is equal in size to CEB, and we now know that CEB and CBE are exactly the same size. We can now say that DHB and DBH are exactly the same size. Therefore, line DB is equal in size to DH. And this is very important, because now we can say that rectangle AKHD is in reality AKBD. Okay? That H becomes a B, and I'll illustrate it right here, right now. So this now becomes a B. Okay? So now you can say that instead of having rectangle AKHD, you now have rectangle AKBD. Okay. Now, we can also say that we have a square on LEGH. LEGH. This here is a square. And we can now say that because of Euclid Book 2, proposition number 4. Because Euclid Book 2 proposition number 4 says that if you were to add the square here, and these two rectangles, which by the way, this is twice of the so in other words, because this thing is the same size as that thing, then it's twice this or twice that. It doesn't matter either way. But now, if you were to add this, and this all together, you come up with this one giant square. Well, obviously that's a square, that's a rectangle, and that's got to be a square. It's that simple. Alright. Now, we have the nomen NOP. And if we add LHEG to that, we're going to come up with the same amount of area as AKBD plus this square right here. But the thing is that instead of using the letters LH, let me have my pen one more time. This L suddenly becomes a C, and this H over here now becomes a D. Because line CD is equal in size to line LH. So now, your nomen NOP plus LEGH equals AKBD. So you got AKBD plus CDEG. CDEG. This square right here. Because remember, LHEG is actually the square of CDEG. That's what it is. So, at the end, the rectangle contained by AKBD plus the square of CDEG equals the square of CEFB. Let me show you that again. CEFB. So, this whole thing right here plus this whole thing right here equals the same amount of area as this whole thing right here. And that's what Euclid wanted you to prove. And you've done it. Alright, I'll tell you more in a future video, so stay tuned.